Glucose. Smash! Da 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 do 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 do. Da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs Class. It's Mr. Kovacs Class. You might learn a ton. It's Mr. Kovacs Class.
It's interesting too.
It's Mr. Kovacs Class.
And he's super cool.
It's Mr. Kovacs Class. Yeah, we're back. Remember my little friend here, the mitochondrion. He likes to do is take glucose and smash it into pieces, and that gives you energy, man. All you have to do to get energy is take some glucose and smash. You'll get some serious energy, right? That's what we talked about yesterday. I introduced some terms to you about cellular respiration. I introduced ATP, and then the three parts: glycolysis, the Krebs cycle, and number 3, electron transport chain, or ETC for short. And we learned that yesterday. Mitochondria, they take glucose and they smash it into cash, right? Smash. It's not really cash, it's not like real money, but it's the analogy I use is that glucose is like a check. It's money, but it's like in a form you can't use. You have to do something to it to turn it into a form you can use. So you need to take glucose and convert it into ATP, much like you would take a check and convert it into cash. Of course, you have to do that at a special place. The place you do that is the bank. Mitochondrion. Mitochondrion can take stored energy of glucose and convert it into usable chemical energy of ATP. It will smash glucose into bits, and by smashing it, that releases molecules of ATP. Glucose cashes your checks. ATP is this big molecule. It's a nucleotide, right? Adenosine is the name of the base pair, adenosine, and then it's got 3 phosphates, so it's adenosine triphosphate, ATP, right? ATP. And what really happens with ATP is it's got energy stored in this last bond, and if you break it, releases something like 7 kilocalories per mole or something like that. A certain amount of energy is released, and it's that energy there that living things use to move things, right? To make things happen, right? If you want to do active transport, you need energy. You've got to break bonds of ATP to do that. ATP is like usable energy. So cellular respiration is how you go from the food that you eat to this molecule, right? And that's called respiration or cellular respiration. And there's 3 steps. Step 1 is called glycolysis. Glycolysis, where you take 1 molecule of glucose and you snap it in 2. You break it into 2 pyruvates. That produces $2 worth of cash, or 2 ATP molecules. 1 glucose, snap it in half, you wind up with 2 ATPs. That's step 1. Step 1 takes 1 molecule of glucose, snaps it in half to make what are called pyruvates, and that snapping in half releases 2 ATPs, or $2 worth of cash that you can spend as energy. Right? That's glycolysis. Step 2, you take the pyruvate and you do what's called the Krebs cycle. Krebs cycle. You spin the pyruvate around a bunch of times, and that releases another $2 worth of ATP cash. Okay? That's right. You take pyruvate and do some chemistry. It's a cycle, so it goes through all these little phases. As I mentioned yesterday, if you were in accelerated or AP biology, you'd need to know all the different steps. But right now, you just need to know that this is called the Krebs cycle, or sometimes called citric acid cycle, and it makes $2 more of ATP. So that we're talking glycolysis and Krebs makes 4 ATPs, $4. Go to step 3. Here's where the real money comes in. Step 3 is called the electron transport chain, and it happens in the membrane. You can see the phospholipids here on the membrane, and the embedded proteins in the membrane of the mitochondria, the inner membrane of the mitochondria, and it basically passes electrons from enzyme to enzyme to enzyme to enzyme, and they change shape, and that generates ATP molecules. And when you're done, you've got something like, you go through the electron transport change, and then you've got something like $36 more of ATP, right? Or 32, anywhere from upper 20s to 30, depending on how efficient your cells are doing electron transport. So yeah, that's what you want to do if you need energy, right? You want to do what's called cellular respiration. You take one glucose, right, and you get 3 steps: glycolysis, Krebs cycle, and ETC. You want it with $36 worth of energy, right? That's what you want to do. 3 steps are glycolysis, you get 2 ATP. Krebs cycle, you get 2 more ATP. In electron transport chain, you get anywhere from 32 to 34 more ATPs. So that's a net of like 36 to 38 ATPs if you do all 3 steps. That's where you get your energy from. Glucose, and you run through what's called cellular respiration. 3 steps: glycolysis, Krebs cycle, electron transport chain. 3 steps: glycolysis, Krebs, ETC. That's cellular respiration in a nutshell, but of course there's exceptions, and we'll talk about those later. Don't forget, tomorrow is our next book talk. All right, so our book talk on our second chapter, or second part of the hot zone. Okay, and coming due today is the photosynthesis lab. Remember, there's 2 parts to it. Part 1 was where you used a test tube and you added the yellow stuff and it turned blue. Part 2, you was the virtual lab. Anyway, that all comes due today by the end of the day. All right, have a great day, and let's do class.